in the previous video, we saw how we can have a solar light, and I received a few comments on that video where people were asking me to give a little bit more context before kind of jumping into the video. So in this one, I'm going to kind of go back to the old paper and pen way and describe to you what exactly we are trying to build here. So this circuit is obviously around about how we can leverage solar so that we can generate electricity. At the same time, we want to have a bit of automation. So that is where the solar automatic light comes in from. The block diagram of the same is very simple. You have a solar panel, which is obviously taking in some sun rays or kind of getting charged with the sun, generating a potential, right? And that is going to a battery. Now, this could be, a battery. In my case, it is a super cap, right? And this gets charged. So there is some kind of way to charge a device and keep and hold the charge in it. And then this gets delivered to the LED or string of LED or array of LEDs if you have, right? Which is basically nothing but kind of your light source. So this is obviously going to emit light. This LED array should, now this is the given requirement of this project, right? So this LED array should only be kind of switched on once it is dark. So when the sun is up here and it is shining bright, at that time we do not want the LED array to be switched on, but it should just hold the charge into the battery. So when sun is up, so this is the given condition. When sun is up, the solar panel should charge the battery, and once the sun goes down or this is no longer available, the solar panel is in a dark shade, at that time the LED should kind of glow and emit light. So this is almost like an automatic night light, or you may call it as garden solar light, or something else. But basically what we are trying to achieve here is the automation part has to be completely autonomous. So we don't need anyone to manually go ahead and switch, flick the switch and stuff like that. So that is the first goal. The second goal of this project is to keep the component count as minimum as possible. So we want to keep it as simple as possible as we can, so that anyone can actually build this, right? So that's the second goal of the project. Now look, so in total, right, this is the project that we're going to build. So we're going to have a solar panel which is going to charge something, and then the light is going to get, or there are supposed to be light elements. In this case, it is an LED, or it could be string of LEDs, which basically emit light at the night, or basically when the sun goes down. So that's the idea behind this. Typical usage of this is, like I said, one could be solar garden lights. The second usage in India specifically could be where we are actually using them to kind of light up in the festival of Diwali, right, which is supposed to be festival of lights. In such cases, this could be used wherein you are actually instead of putting a load onto the electrical grid, you are actually charging your Diwali lights from the sun, and once the sun goes down, it automatically switches on. So that's basically, that is another use case where we could have such kind of a circuit. Apart from that, you might have simple night lamps or night posts or even street lights which could adopt to this. So the circuit that I'm going to kind of show you, or I'm going to build out right now on the breadboard, is quite a bit of small circuit. So it has it's the solar panel is very small, and it typically kind of generates voltages in maybe max 5 volts and maybe 1 milliamp max. That is what the that's the wattage that we are handling here. So just to show you how this can be effectively done, basically I'm going to use such kind of a very small power solar panel and demonstrate to you the same thing. So that's it. Let's go into the component list side of the solar panel, of the solar light, and see what all we need. So on the component side, simply what we need is, obviously we need some kind of a battery or some kind of a storage device for the energy that has been kind of got from that we get from the sun. And this is going to be my storage device. So this is a typical 5 volt 4 farad super cap, right? So This is what I got from eBay again, and these are really cheap. They do not have that high amperage, or they don't kind of deliver that much of an high ampere current as normally supercaps do. They do have a very high ESR, I think, and this guy kind of max out at 200 milliamps if you short circuit both the ends. So any which ways, but this still kind of holds a lot of energy. So this is my battery in this case. So this is what I'm going to use. The second thing around this would be obviously some LED or some light arrays, right? So this is something that I'm going to use for the light arrays part of it. So this is a this is a light basically used to work on three AA batteries. It had a built-in internal resistor for current limiting, and then it parallelly goes out to all this LED arrays basically. Those are all connected in parallel, and they light up. So it's going to be a warm white color. So this is basically what I'm going to use for my or to drive the circuit out of this. So this is an example load that we'll be using. The other things that we require is obviously a solar panel. So this is my tiny solar panel that I have. This I got off from a solar power bank. Yeah, if I remember it right, solar power bank, and this is having very low voltages. So it's almost like around about, it generates 5 volts at 1 milliamps and stuff like that. So the power is quite small. Apart from that, we need a few components. Obviously, the first one would that we require is a good breadboard. So that is one thing that we are going to require. So let me quickly grab one. Yeah. So we're going to require good breadboard. So this is one. This is mine. What I'm going to use. Then we obviously require a MOSFET, and this is what I'm using. This is again an IRL MOSFET, so this is a logic level MOSFET that I'm going to use. Apart from that, we are going to require one resistor, and this is a very tiny resistor. This is 33 ohms. We can bypass that if you want, but then in my case I'm going to drive simple LEDs as well, just to show you how it works. So this is the current limiting resistor that I will be using. So this is a 33 ohm resistor. That is part one, and then obviously you need a diode. This is a normal rectifier diode. This is 1N548519. Yeah, possibly something of that's the part number. But this is normal diode. It has a forward voltage drop of 0.5 volts, which is like 500 milliamps, 500 millivolts. So that's the forward drop voltage. So this is another part that we require. Apart from this, yeah, we require some few jumper wires, and obviously we require our trusty old power meter that we kind of did in the last video series. So this is the same power meter that I'm going to use to show you how how the circuit is behaving and stuff like that. So that is the part, and obviously we require some kind of wires so that we can connect our super cap to it. So those are some alligator wires that we are kind of using. Yeah, that's almost it. And obviously, yes, you need some kind of a light source. So in this case, my table lamp or my makeshift light that you see here is going to work as my sun, which will basically help us generate some electricity out of the solar panel. So that's for the component list. Now we'll quickly dive into the schematics part of it, which I've already kind of simulated in the last video, but I'll quickly go over that again. Okay, so coming back to pen and paper, which I think gives you the best way of what we are doing. So again, so I'm going to draw the schematic for this night light, and this is very simple as it goes, right? So you have a solar panel here, right? So let me just quickly draw a solar panel. I might not be correct with the symbols, so please excuse me on those. So this is like a plus minus solar panel that you have. The solar panel goes obviously here, and it charges the super cap. So I'm going to draw an electrolytic cap, if I'm not mistaken. This is the right symbol, and obviously this has to be charged via a reverse blocking diode, right? So sorry, and the diode that we just saw, this is how the charging of super cap will be, right? So this is like 4 farad, 5.5 volts. Okay, and this guy is a solar panel. Now the interesting part, or the automation part, and this is where the whole thing comes in. So you have a MOSFET here, right? So I'm just going to draw it as a not the real symbols, but maybe something similar to it. You have a resistor which is connected to it, and then you have this guy connected down, and the gate connected down here. Right, so this is how the whole thing is going to work. I know my symbols are not right, and maybe I'm not excellent at drawing this. So this is going to be the gate, this is going to be the source, this is going to be the drain, right? So this is how the whole circuit will look basically. What happens is, in the normal flow of electrons, right, this guy is going to go and charge the supercapacitor. So the current flow is normally going to be this way, right? So the current will start flowing through the circuit. Let's say it is the supercapacitor is at 0 volts, right? In such a case, what is going to happen is the solar panel starts receiving some kind of sunlight. It starts building up voltages, and then the current flows through the circuit, through the supercapacitor, right from here through the diode, and then it goes back again. So you have an unrestricted path for the current to flow when the solar panel is active, or when there is some light on the sun from the sun. Once the light from the sun stops coming in, what is going to happen is the super cap. This is obviously going to kind of go back. This is not going to. There is no light, so obviously there is no voltage developed across this, and there is no current flow in the whole circuit. So the current flow in this direction is going to be 0. Right, and obviously to measure this current, what we are going to do is we are going to hook up our power meter here, right? So it will be across these two things. So this will be like from the capacitor side, and we'll have a power meter here, and then we can put it across the circuit. So just so that we know what is the current, what direction the current flow is in, and how it is working and stuff like that. So this is going to be our setup. Right now, as I explained, when the sun is up, you'll kind of see a charge going through like this. But when the sun is down and there is no charge, what is going to happen is this super cap is going to start flowing current in this way, right? And when it reaches the solar panel, a property of the solar panel that we're going to exploit is it behaves like a diode when it is not in sun, right? So in this case, it behaves as a reverse diode. So what happens is this reverse diode has quite a bit of leakage current, right? Whenever it is in reverse bias, there is a small amount of very leakage current wherein that passes through, and it passes through this guy, right? And when it comes here, this is the point where it is actually blocked, or there is no current flow, right? So what happens? A simple thing happens. The voltage at the gate now is basically positive. Now this being an N-channel MOSFET, when you apply a positive voltage at the gate which is higher than the source voltage, right, the MOSFET turns on, right? So in this case, what's going to happen is the MOSFET now sees a positive voltage on its gate compared to when the solar panel was charging it, because at that time it was all negative here, right, and we were not seeing anything. But when the reverse happens, there is a positive voltage that has been developed, right, or it gets to a higher positive potential voltage, the gate, and this guy starts conducting, right? So when it conducts, it will start bringing it will act as a switch. It will act as a closed switch, and it will try to connect this point and this point, right? When this happens, there is a current flow through this path. Now if I put an LED here, or a string of LEDs here, what is going to happen? The LEDs are going to light up automatically. So this is the basic working principle that we are going to look at in this circuit, right, which will help us to kind of see how the whole thing works. So I hope you understood this. If not, you can refer back to my previous simulation. I have kind of drawn it very badly here on the pen and paper approach, but then you can go back to my simulations and see how the whole thing works. What I've only done in the simulation is I've substituted this part with a switch, right? So I've made a switch there which says when it is in dark, this path is active. When it is in light, or when the solar panel is producing some voltage, this path is active. So I kind of flick the switch just to simulate two different conditions, the light and the dark conditions. But anyways, this was a complete overview of the schematics and how we're going to build it. Now this